Hi and welcome everyone. In this video we are continuing to work on our small example game, and in today's video we will add physics to it. And why we need physics? Well, because our current implementation is just fixing the position of the character. So if I change this value to 200 pixels, you will see that our character will be floating in the sky, and you're not expecting to see something like this in a game. Well, maybe you do, but it's quite strange, and we want to have a gravity force that applied to our character. And how we're going to do this is by using Froobit's Froobit ability to specify physics features to your entities. And one general thing about physics in Froobit is that Froobit uses planck-js, and planck-js is a rewrite of Box 2D physics engine. And I added planck-js because Box 2D is a great engine. Many people are familiar with that, and I think it's going to be very easy to start working with physics in Froobit. And Froobit by default will create a world. If you start adding physics to your entities, it will create a world with a gravity force. So you will see in a moment how it looks and how it works. But before we start working on the code, I want to show you some basics about the physics and how it's going to work in this example. So let me just draw a bounding rectangle around this character. So this is what we're going to define as a shape around our object, and in the planck-js world we need to define this as a body first, which has its position, and then we add a shape so that we can detect collisions. Well, planck-js will detect collisions for us, and we also need to define where the ground is, and it will be static object and will not be influenced by the force of gravity. So for now, let's go to our character first, and let's start implementing physics here. So you start by defining a physics method in which you will accept argument object with shape method. Now you call shape, and the shape will accept callback, which accepts Planck instance. So this might look weird, but this is how it's implemented, and I think it's really cool to do it like this way. So you can actually call methods on planck-js like box, and then you can say 32 by 47. And one thing before we create this bounding box around our character, we need to know that planck-js will accept only world coordinates. So for that purpose we have a pixel to world utility method, conversion method, so you can use it here like this. And we need to return this. So this is going to be a bounding rectangle shape around our object, and actually it is called body, and you can access the body like this. And now we can access body from other methods, from the render, because in the render method we will need position. So basically engine will calculate the position of our object, and we will just going to draw our image on that position. And let's do it. Let's now define x and epsilon coordinates, and we will need to translate vector to coordinates in our world, in our pixel world. And now we access body, get position. Now we can do translations. Now you can see that basically nothing happens, everything is the same, but if we use a dynamic function from the argument object. We can call it here. Our body, our object will become dynamic and it will be influenced by the force of gravity. So let's refresh the page. And now you see that our little character is falling and there is nothing that can stop it from falling. What we actually want to do, we actually want to set the initial position of our character here, and we don't want to have this translation in the controller. So controller will be very simple. It will just return a character, and we don't need this and this as well. Now we can position our character like this: body, set position, and we will use one more utility method called chords to vec2. So you now see that the character is drawn in the position 0, 0, 0, and let's change this. So let's draw it in the middle. Our canvas is 800 by 500, so let's put it on 400 by 250. Now the character is again in the middle, and maybe I should put it higher, like 50. So now you can see that it is falling, and what we now need to do, we need to create this edge shape, so edge to edge shape, which will be static and which will prevent our character from falling out from the canvas. And we do that just by going to our background, and we can go to, for example, front background and implement physics method. Here we use shape again, same as before. This callback will accept PL instance, and we call PL edge, and it actually accepts vector 1 and vector 2, so we need to define those, and we'll use coordinates to vector 2 conversion method. And x value for the first vector will be 0, and epsilon value will be 450. The canvas is 800 by 500, and vector 2 will be positioned at 800 by 450, and we just defined the shape like this. And I forgot to return the shape actually. So you can now see that if I refresh, the character is actually stopped from falling, and we can now basically even move as it is jumping around. So this is how easy it was to add physics to this game example. So we basically defined our shape for the character and the shape for the ground, and the shape for the ground is really simple, just edge to edge, as you can see this, and the shape for the character is attached to a dynamic body, and then we're reading the position of that body and translating our animation by that position. So that will be it for this tutorial. Thank you for watching, and see you in the next one.